previous class we have discussed about the introduction to the Verilog. Yeah, so what is this? What happened? Yeah, in the previous class we have discussed about the introduction to the VHDL. Sorry. So in that we have discussed about the VHDL and Verilog, and then VHDL will consist of two parts. One is entity and architecture. In that entity we are going to have the generic declarations and port class declarations and entity declarative items. We have completely discussed about the entity part. Okay, now we are going to see about the architecture part. Okay, so if you haven't also watched those videos, so you can check out in my channel. You can able to see the video. Okay, then only you can come to the this next part. Then only you can able to understand in a very detailed manner. Okay, yeah, there will be a continuity. Okay, yeah, sorry, yeah, this all things we have discussed. Now we are going to discuss about the architecture declaration. So without any delay, let's move into the video. Yeah, architecture declaration. Architecture, we will specify the behavior of logic circuit. Okay, then where we are going to specify the both inputs and output ports declaration, we are going to do it in the entity part, right? Yeah, so we are going to specify the behavior of the logic circuit. Okay, in the entity part we are not going to do any specify the behavior relation between the inputs and outputs. Okay, in that only we are going to declare the both inputs and outputs or any generic constant if available. We are going to declare those, but the heart and the logic between the inputs and outputs we are going to specify it in the architecture. So the name architecture came from it. Okay, architecture means simply the connections between the components, right? For the simple understanding. Okay, it shows the relationship between input and output for any logic circuit. Okay, yeah, architecture should be followed by should be followed for an entity. Okay, it means what are the inputs and outputs that we are going to declare in the entity. For those inputs and output names only we have to use in the architecture. Okay, and then we should form the decide or the uh, relation between those. Okay, it means it must follow the entity. Okay, it means we are going to declare the inputs and outputs in the entity. Okay, for those inputs and outputs names only we should uh, uh, write the logic in the architecture. Okay, we shouldn't take any other names. Okay, that's the meaning of this point. Okay, architecture should be followed for an entity. Next, VHDL program consists of entity and architecture. Okay, where in entity we are going to specify the what are the inputs and what are the outputs and what are the generic content, all this stuff. Where in the architecture we are going to build the relationship between the inputs and outputs which we have specified in the entity. Okay, combining both these particular entity and architecture, we will get a complete VHDL code. Okay, in the previous class we have discussed about the entity. Okay, very deeply. If you haven't watched it, please watch it. Yeah, syntax for the architecture. Let us see the syntax for the architecture. Yeah, sorry for the interruption. Next, architecture. Okay, architecture is a keyword. Architecture name. Okay, architecture name is a user defined. It means whatever we want, then that particular name we can use. Of is a keyword. Entity name is a user defined. Okay, entity name is a user defined which we have given in the entity itself. Okay, that's the meaning of architecture should be followed for an entity. Okay, before it we are going to write the entity, right? Before it we are going to write the entity part. In that entity part, what name we are going to use for the entity name, that particular name will be used here. And is a keyword, and in this we are going to write the architecture declaration part. Okay, we will have some architecture declaration part. That thing we are going to write in it. After we are going to write the begin. Okay, begin is a keyword. From begin, after the begin, we are going to write the concurrent statements. Concurrent statements, the statements that are going to execute in the parallel manner. Okay, it's not going to execute one after another like we are going to see in the C language. The statement that are executing in the parallel manner. Okay, where we are going to write the relationship between the inputs and outputs. Okay, and then after writing the those all relations, we need to end and then architecture name. Okay, followed by the semicolon. Next, architecture declaration part. It means now we are going to see about the architecture declaration part. Okay, in the architecture. Okay, architecture declaration part. Architecture declaration will specify any intermediate signals. Okay, in the entity we are going to specify the inputs and output ports and generic constants and also declarative items. Okay, in that only in that also we can specify signals and types and any intermediate signals if available. Okay, if not, then we can specify those intermediate signals in the architecture itself. Okay, intermediate signals means those are not the inputs or those are not the outputs. Okay, those are in between the inputs and outputs. It means the those signals that we can't able to see externally. Okay, okay, whereas the signals that we are going to see externally are the inputs and outputs. The signals that we are going to see the externally, those are the inputs and outputs, so that those things we are going to specify in the entity. But the internal, okay, which we can't able to see, okay, those signals will be specified in the architecture declaration part before the begin. Okay, after the specifying the architecture name is, okay, it means let me show you. Architecture name of entity name is, after the this we are going to specify the architecture declaration part. In this part we are going to specify what intermediate signals. Okay, what is meant by intermediate signals? Two signals we can't able to see externally. Okay, what are the signals that we are going to see externally? Those are the input ports and the output ports. Those things we can able to declare in the entity part itself, but the internal intermediate signals will be declared in the architecture declaration part, which is before the begin. Okay, when the begin came, after the begin we are going to write the relationship between the input and output. Okay, before begin we are going to do this. What is this? It means declaring the intermediate signals. That particular thing is called architecture declaration part. Signal declaration, constants or any variable. Okay, here also we can able to define any constants or any variables we can if we need it. Next, concurrent statements tells the behavior of the logic circuit. So this is the point I have told you, right? Behavior of the logic circuit means in the concurrent statements we are going to specify the input output relation. Next, that is input output relation, right? Specifying that particular input output relation will be in three types. Okay, we can specify that particular input and output relation between the inputs and output ports or the constants. We can do that thing in three ways. That is called levels of abstractions. Okay, after begin we are going to use the concurrent statements, which are used to specify the relationship between the inputs and outputs. To specify the relationship between inputs and outputs, there are so many ways. How many ways? Three ways. That thing which is called as the levels of abstraction, those are three levels. Okay, there are three levels of the abstractions. Any of them, any one of them you can able to use in your design. Okay, why three? Using one design you can able to get least power. Using some other level of abstraction you can get power low. You can using another levels of abstraction you will get delay low. Okay, like this it varies. Okay, the parameters, okay, at the end we are going to take the area power delay parameters only. We are going to, why we are going to learn all this means to reduce those parameters, right? Okay, using these three levels of abstractions you can't able to get same all the three parameters, basic parameters, area, power, delay can't be same for the large designs. For the small designs it can be same. Okay, for the large designs there will be chance of variance between the three levels of abstraction. Based on that we will choose our required level of abstraction, right? We will perform comparisons between these levels of abstraction. Okay, and after performing we will write the parameters, individual parameters. Okay, and then we will compare those parameters and we'll take our desired design from that uh, comparison. Okay, for example, if you are having the half adder, then you are going to write the codes in three ways using the three abstraction levels, and then you are going to note the parameters individually. Those are area, power and delay for the three levels of abstractions of half adder, and then you are going to compare. Okay, in one design you might get area low, in another design you might get power low compared to all three. Okay, in the another design you may get delay low. So if your requirement is having the low power, then you are going to use the then you are going to use the that particular design which is having the low power among three levels of abstraction for that same design, right? If your requirement is having the area to be low, then you are going to choose the design which is having the least area among three levels of abstraction for the same design. Like this we are going to do, right? So we can specify the logic relation between the inputs and outputs using the concurrent statement. These particular concurrent statements can be of three types, or the three levels of abstractions we are having. What are those? Let's see. One is behavioral model. So we are going to specify the behavior based on the truth table of the design. What is meant by truth table? In the digital electronics we are going to see, right? The input output relation between the design will be called as truth table. Okay, we are going to take the inputs and outputs. We are going to take the input combination, possible combinations of here. If you are going to take the 2 bits, then there are total 2 power to 4 input components, and applying those 4 inputs we are going to get the corresponding outputs for these inputs, and that particular table is called truth table. By using that particular truth table we can able to write a code. That particular code in the concurrent statements, that particular thing is called behavioral model. Okay, in concurrent statements if you are going to write code based on the truth table of the design, then that particular design will be called as behavioral model, data flow model based on the boolean expression. Okay, we are having the truth table, right? We are going to minimize the expression of the design using the k-map, then we are going to get the boolean expression of the output in terms of input. Okay, using that particular boolean expression of output in the form of input. Okay, using that boolean expression of the output which is made up of inputs. Okay, we are going to write a code. That particular level of abstraction is called as data flow model. Next, structure model based on the internal architecture of the structure. Okay, we are having a design. The design is made up of several internal components. Again, the internal components are being made of some other internal components. Okay, it means like an atom. Atom is not breakable, but it can be breakable. Atom is not breakable. In atom there is some people so I'm debating, let me tell you. Some people tell that atom is indivisible, indivisible, right? But some other people tell that it is wrong. In atom there is electrons, protons and neutrons. Okay, how can you break that electron? Can you break that electron? No, right? In the electron is the least particle, right? In the atom itself, right? So till that point, okay, our body is made up of matter. Matter is containing of atoms. Atom is containing electrons and protons. What does the protons and electrons contain? Can you tell that? Yeah, of course, it may consist anything, but we can't able to tell, right? So similarly, we are having a large design. Okay, that particular large design is made up of small components. Again, those small components are made up of some other small components, right? Again, those components are made up of some other components, and till then we are getting the least component as to be the gates, right? Using the logic gates only, we are going to make any large design. It means the least component is logic gate. Again, these gates are made up of transistors and all the stuff, but it is completely related to the analog electronics. Okay, yeah. So next, using that particular architecture structure, we are going to write the code. That particular code is called the structured model. Yeah, so let me clarify everything till now what we have discussed again. Okay, you need to have this assessment. Okay, we are going to have a VHDL program. A VHDL program is consist of two parts. One is entity and architecture. Entity is again consisting of entity in which we are going to specify what are the inputs, what are the outputs, and what are any generic constants on any entity declarative item. So we are going to specify those things, and then entity part is completed. Okay, then in the architecture we are going to specify the logical relationship between the inputs and outputs which we have mentioned in the entity, right? We are going to write the architecture followed by the entity only. Okay, we are going to write the architecture for the entity values only, right? Right, so that only we are going to use the architecture name of entity name. Okay, is okay. Next, if you are going to have any intermediate signals in the design, what are intermediate signals? Those signals which we can't able to see externally. Okay, the signals which are going to see external, those are the inputs and outputs. Other than those signals, everything is an intermediate signal. Okay, yeah. So those intermediate signals can be declared in the architecture before begin and after architecture name of entity name is, right? After this thing, we are going to use the begin. In begin, after begin, we are going to write the concurrent statements. Concurrent statements, what are the concurrent statements which are executed in the parallelly, and those concurrent statements are going to specify the relationship between the input and output. These particular relationship can be specified in different ways. Those thing is called the levels of abstractions. In total we have three levels. Those are the structural model, behavioral model, data flow model. Behavioral model is based on the truth table of the design, and structural model is based on the internal architecture of the design, whereas the data flow model is based on the Boolean expression of the design. Okay, I hope you got in clarity. Next, yeah. So I think just a second. Okay, that's it for the video. So I think you got a complete clarity of the structure. Okay, it is very important. Okay, some people don't know what is the structure, why we need to write, why we need to do this, why we need to code this, why these three levels of abstractions, why should we have like this. If you are going to have only one type of abstraction, okay, if you are going to have only one type of abstraction, then AI also can able to do it very easily. Okay, there are three types of abstraction levels, so that you need to perform same design in three levels of abstraction. You need to compare the parameters of the area, power and delay, and then you must tell which one is better for low power consumption applications, and also which one is better for the area low area applications, and which one is better for the low delay applications. Okay, everything is about the comparison. Okay, I hope you got this video, and I think I have covered everything, right? everything about the VHDL programming part, which is from VHDL code consists of entity and architecture. Okay, if you haven't get the clarity, then I will tell you. You just be a second and think what I have told you, and you form a map, mind map, or the flow chart. Okay, VHDL program. In that VHDL program, we have two types: entity, architecture entity, consisting of specifying the inputs and outputs constants. And in the architecture, we are going to specify the logic for that entity. Okay, architecture is always followed by the entity. Okay, specifying that particular logic can be done in the three types. Those are the levels of abstractions. Call as levels of abstractions, and those levels are data flow model, behavioral model, and structural model. Right? I hope you got this, and thank you.